All right, we are starting the second half of 5-6, and today we are focusing on the discriminant. So, as we fill in our notes here, we have the word discriminant. The discriminant is part of the quadratic formula that you use to determine the number of real roots to a quadratic. So the discriminant is not actually going to tell us the answer. It is going to tell us how many answers we have and what type they are. If you look, the discriminant is the number right underneath the square root sign. So as a reminder, we have the x equals negative b over 2a. And again, that is our axis of symmetry, which helps us find our vertex. The discriminant is simply b squared minus 4ac. Notice that the square root sign is not a part of it. So the discriminant is what we would be taking the square root of to solve. So when we do this, we still want our standard form ax squared plus bx plus c. We want it equal to 0. A can't be 0 because if a is 0, it's no longer a quadratic because we don't have x squared. The discriminant formula again is b squared minus 4ac. So I'm recommending a note card that has your quadratic formula on it, the standard form of a quadratic, your discriminant, your axis symmetry, and all other rules, and then you're going to add these rules to the mix. If our discriminant, b squared minus 4ac, is greater than 0, and what's that really mean, greater than 0? That means it is a positive number. If my discriminant, the number underneath the square root sign, is positive, I can take the square root of it, and I will have two real solutions. I can go further with this. Having those two real solutions, I can determine if they are rational or if they are irrational. If I have the square root of a perfect square, like 36 or 16 or 25, those are all perfect squares. They're numbers I can take the square root of, and I will get a rational answer. So if my determinant is a perfect square, then I will have two real rational solutions. Remember, a rational number can be written as a fraction, decimal, or repeating decimal. If I have the square root of anything else, like a 14, a 17, a 21, then I will have an irrational answer. So if it is not a perfect square, I will have two real irrational answers. And again, if you notice, anytime I have two real solutions, I will have two x-intercepts. That is me finding x when y is 0. All right, if my discriminant is actually equal to 0, let's just think about that for a quick second. If it's equal to 0 and I have something like negative 5 plus or minus the square root of 0 over 2, I'm only going to get one real solution because negative 5 plus 0 is the same as negative 5 minus 0. And so I get maybe a fraction, maybe a whole number, maybe an integer, but I will only get one outcome. And so that's when the vertex is your only x-intercept. This also means that I will have a real but rational solution because 0 is a perfect square. So not only do I know how many, I can get the specific type of answer. All right, if my discriminant is less than 0, meaning the number underneath the square root sign is negative, well, I cannot take the square root of a negative without imaginary numbers. So the equation has no or 0 real solutions. But I would like to get more specific. It has no real solutions, but it has two imaginary. So we now can have the number of solutions and the detailed type of solutions whenever we find our discriminants. All right, so let's look at some examples here. The first one's laid out for us. We want to just find the discriminant to find the type and number of solutions. So you have three parts to your answer. What is the discriminant, how many, and what type of solutions do you have? First thing I want to do is I always want to set it equal to 0. So whether it's f of x or it's already set equal to number, move that 7 over by adding it, set it equal to 0. Here is my formula for the discriminant. The parentheses are extremely important because if I'm squaring a negative number, like my -6 squared, then I want to make sure that I have it correct in the calculator. So -6 squared minus 4 times A is 1 and C is 7. So I am really pulling this part of the quadratic formula. Notice that I am not doing anything with the square root symbol. That's not part of the discriminant. So this ends up being 36 minus 28. All right, so 36 minus 28, I get I get 8. So my discriminant is greater than 0. That means I have a positive outcome, right? And so I have two distinct real solutions, but let's get more specific. The square root of 8, that's where it would go, is underneath that square root sign. The square root of 8 is not a perfect square, so I am going to get two distinct real solutions, and they will be irrational. All right, next idea, we have another problem. I'm going to set it equal to 0. If it helps you to pull your A, B, and C, go ahead and pull that. A is 1, B is -6, C is 9. We're going to plug it into our formula. So -6 squared minus 4 times A is 1, C is 9. And then I'm going to simplify that. I get 36 minus 36. So my discriminant is 0. So that's part of my answer. That means my B squared minus 4AC is 0. I have one distinct real solution because when I take the square to 0, it does not change the problem. This will be rational because the square root of 0 is a rational number. All right, one more example here. We have x squared minus 6x, add that 11 over to set it equal to 0. And I will plug it in to be -6 squared minus 4 times 1 times 11. All right, so I still have that 36, but this time it's minus 44. Put this together and I get -8. All right, remember, this discriminant is underneath the square root sign. Can I take the square root of a negative? No. So I will have, first of all, my discriminant is less than 0. That means I have no or 0 distinct real solutions. Specifically, I have 2 imaginary solutions. So we are not solving, we are only using the discriminant to determine our outcomes. So let's do 3 more practice examples. This might be where you want to pause the video and try these 3 on your own and then check them. So I have x squared minus 4x plus 4 equals 0. Plug it into our formula because you're working so hard and following along. And we end up with 16 minus 16. That gives me a discriminant of 0. So that is part of my answer. And now that I have discriminant 0, I will have one real rational solution. So I only get 1 because the square root of 0 stays 0. I'm adding, subtracting, 0. All right, set this equal to 0. Add the 8. Plug in our formula, -4 squared minus 4 times A times C. And I get 16 minus 32, which gives me a -16. Well, with that -16, I cannot take the square root of it. It's less than 0. So I get no real solutions. But again, I am looking for the details that I get 2 imaginary. All right, last example on our discriminant. We have x squared minus 4x and then minus 2 equal to 0. Put in your formula, -4 squared again, minus 4 times A times C, and we simplify that. And I'm going to get a positive 8, a negative times a negative, and so I end up with 32. And that gives me 2 real solutions because it is greater than 0. The next question is, are they going to be rational or irrational? Well, the square root of 32 is not a perfect square. So when I put it in the calculator, I will get an irrational number. So I get two real solutions that are irrational. So that is how we use our discriminant. And we will finish these ideas with the word problem on another day, and it's using the quadratic formula.